Circuit protection of embedded systems is critical for any application, particularly in the automotive market where vehicle power can be hard on electrical systems. As the world starts to transition from the combustion engine to electric vehicles, how are circuit protection needs in the automotive industry changing, and what considerations do we need to make as in our EV battery and recharge systems? Embedded engineers gaining an understanding of how these new electric vehicle systems are designed and how the charge stations work are absolutely critical to our discipline and something that we're all having to work very hard at. We're all looking at ways to maximize the efficiency of battery usage, maximize minimize the power and heat losses from actually doing the recharge on those, and also minimizing the size of what ends up being very high power circuitry in our designs. But sometimes what gets overlooked in these EV recharge systems is the idea of protection circuitry, and there are some special considerations that we as engineers have to make as we're designing that into our systems. Today I have the privilege of speaking with Pete Pytlik, FAE Manager at LittelFuse, and an expert in this area who's helped a lot of engineers in their electric vehicle systems. Pete, thanks so much for joining me on The Current today.
Todd, it's great to be with you.
Yeah, really appreciate it. So talk to me about this. This is obviously a hot topic really throughout the world, not just in our industry, is really the electrification of everything. When we're looking at an embedded design and the protection required in an EV system, what are the things that we need to consider in an electric vehicle that maybe we haven't had to consider in the past in our combustion vehicle designs?
Todd, that's a great question. With the advent of hybrid and then EV vehicles, the electronics content has significantly increased. So protection devices, components that were typically used in electronics, general electronics, portable type applications, may not, and also in most cases, will not survive the harsher environments. In EV type applications, e-mobility type applications. So it's really critical to look at these components that they meet the temperature requirements, thermal cycling requirements, vibration shock. Again, this is an environment which is going to be much more harsher than general electronic type applications. So it is critical to look at those and make sure those components, in our case, overcurrent or over voltage, have those ratings and certifications. If we look at an EV vehicle, we can actually divide it into a few segments. We can look at the low voltage side, high voltage side, and it'll be an associated low current, high current. So body electronics, cabin, motor train. When we look at these types of systems, they're going to have some type of control logic, okay? Right. Control logic is generally going to be low voltage, in most cases 12 volt type of system. Mm-hmm. So protecting that type of system from an overcurrent event is going to be critical. Yeah. So what is an overcurrent event and what are overcurrent protection devices? So an overcurrent event is really when you have a short circuit or some type of overload condition in the application. So what an overcurrent protection device does is it's really, and if I would back up, say, well, what are we trying to protect? What is we're trying to protect against? Is those types of failures, but the overcurrent device is actually the weak link. So if there is a fault scenario, you do want to protect the wiring, you do want to protect the PCB board traces, right, and also protect other types of components on the board. So it is critical that those types, the low voltage, low power electronics, and also in addition, the higher powertrain, higher current electrical systems be also protected, and to make sure those components are rated for the harsher environments. Again, vibration, shock, those types of considerations definitely need to be looked upon.
Right, and it's interesting because when I think of my combustion engine and doing work on my own vehicles at the house, that seems like an incredibly harsh environment to me. My experience there is, anytime the alternator comes on, anytime you hit the ignition, the voltage spikes go through the roof, and you got to be kind of prepared to deal with that. It sounds like in an EV system, it's not so much voltage spikes and things like that; it's current that we're really more worried about in an EV. Is that a fair statement?
It would actually be both. So you are
Okay.
looking at
Okay.
overcurrents, and you are also looking at over voltage. But if we look at
Okay.
if we look at the overcurrents parts, okay, so when you do have your EV vehicle charging, okay, so chargers come in basically three different types. You have your AC, your DC, and your wireless type of chargers.
Right.
So the AC, the level ones, the level twos, these are the residential types of chargers. These are mainly
Right.
pass-through type of chargers where you're just passing through the AC to the vehicle, to the onboard charger. Mainly that's done through a contactor
Okay.
in the charger, the offboard charger itself, okay? So you do have design considerations you do need to be mindful of there. The main AC power, make sure those are fused in case there is some type of overcurrent events. You don't want the contactor to fail. And then also you're going to have your control electronics, making sure that those lines are fused. Again, various types of fault scenarios. And I'll also say the over voltage part, make sure if there is any type of voltage spikes, those are also suppressed.
Right. Right. Okay. Makes sense. So that's really what we've got to consider as we're doing the charge system that goes into our homes, or even I assume the same considerations have got to be made in an infrastructure charge system at a store or at an office building. We've got those considerations, but then as we look at expanding more and more of us going to electric vehicles, we're going to end up in a situation where we're putting a bit of a strain on our overall electrical grid. What kind of things are necessary for us to consider there? And are there considerations in the electrical grid and the infrastructure expansion that's going to be required for electric vehicles that LittelFuse is involved in?
Sure. So some of the trends that we're seeing is when you look at infrastructure, microgrids are becoming very popular. So in a microgrid, it's really kind of a self-contained system. So it may or may not connect to the electrical grid. It may have a PV input. It may have a BES system, a battery system.
Right.
So when you look at those types of systems, overcurrent protection is going to be critical. When you are connecting to the AC grid, you're going to be then converting that. Generally, this is going to be larger power, larger voltage, larger current. So making sure that those AC lines and the DC lines now are protected against overcurrent.
Right. Okay. Makes sense. And then beyond that, if you're in a home where you're wanting to get entirely off the grid, and as more and more houses are installing solar and other green energy solutions, they're looking to be able to store that in in-house battery arrays. Sure. And things along those lines. Are the differences in the way that we should consider those batteries that are storing energy in our homes to get us fully off grid reliance, and the ones that maybe the batteries that are in our electric vehicle itself, or are those pretty much the same considerations we need to be looking at from protection circuitry?
Todd, those are for the most part going to be the same. Okay. Just on a larger scale. So looking at residential homes, home power, you have a great point. Really where it's going to go and really where it's starting to trend is being able to store power at home. You're going to have a battery type of system. It may have a PV input. Or your vehicle itself, the battery capacities will increase. You may have a bidirectional converter. So in some cases, you may be able to use the power from the vehicle as a backup power source in addition to your home BES system. So when you look at protection of batteries, whether it's the residential BES system, whether it's onboard, it's going to be very similar. You're going to have the battery unit itself, generally divided into modules. For larger scale systems, they're going to have more modules. But when it comes to protection, when it comes to protecting the battery management energy system, very similar. Low power, high power, making sure the DC, the AC is protected against overcurrent.
Right. Makes sense. And then, in a situation, would you design the circuitry differently if you've got a vehicle that can essentially the current from the battery can go either way, where maybe your car at home is charging your house? Are there differences in the way you would design that circuitry and that protection circuitry as opposed to just a device where it's one way? The current's always going to be flowing from the charger to the vehicle. Now you're in a situation where it could go either way. Does that protection circuitry look different?
It really depends on the actual architecture and configuration of the system. But generally, when you do have a bidirectional, now you really need to be mindful of protecting not only the AC, but also the DC. So if there is a fault on the DC side from the vehicle, you do have the protection there. And then also on the AC side.
Okay, that absolutely makes sense. So maybe you can get into a little bit more specifics for me. You know, when it comes to LittelFuse themselves, you guys have an absolute wonderful reputation as far as protection circuitry in the industry. You know, in the technology that you have, are there specific areas and unique technologies that you're investing new R&D into to be able to expand your position in this space? And are there specific family members that we as embedded engineers should be considering for LittelFuse in our designs?
Sure. So last year, Todd, we celebrated 95 years of being in business, and we've been developing components for traditional combustion type automobiles since almost the beginning. It's been a focus area for us. And within the last 20 years, the e-mobility segment, EV type applications, we've been following that very closely, partnering with those manufacturers. Developing new products, really trying to be on the leading edge. So specific examples, overcurrent. Smaller type packages, surface mount is a trend. The voltages are going higher, so are the currents. So we're looking at different integrated type solutions. It may be just, a traditional fuse, which may be resettable also, have some of those features. It may be integrated with solid state type of devices. So those are the type of solutions we're looking at, from an R&D engineering perspective, really trying to be, again, ahead of the curve, making sure we provide those innovative solutions to our end customers as the market evolves.
Right. Okay. Excellent. Excellent. And that's where, that's an area that I think we've got to be looking more at is as embedded engineers. We've got to understand what's the next latest and greatest in protection circuitry. What should we be considering for the next generation of designs? And it's exciting to hear that LittelFuse continues to invest in that area because I think we're all going to need it more as all of this change of electrification of our world continues to grow and expand. We're going to have solutions on that protection side to meet that new demand and new problems that arise from that demand, which is really exciting. So very good, very good. Well, Pete, thanks so much for joining me on The Current today. Really appreciate you sharing some of your knowledge and expertise when it comes to protection circuitry and electric vehicles. And I think we're only scratching the surface of the conversation that can be had in this area. For our viewers, if you have questions on your EV designs, whether that be on the electric vehicle side, the charger side, or the home energy storage side, we at Future Electronics are here to help you and your engineers. We would love to sit down with our engineering team, the LittelFuse engineering team, and bring some solutions and conversations with you to the fore so that you can have a better understanding of the options out there to how best protect your circuitry. Thanks so much for joining us on The Current today. We look forward to seeing you in our next episode. And if you have any desire to speak with Future Electronics or our engineering team or speak with Pete, please reach out to me at Shaping the Future, one word, Shaping the Future at futureelectronics.com, and we'd be happy to speak to you soon. All the best.
Thanks, Todd, and thanks for the opportunity.